Hey, 30-2s. Here is your second lesson on polynomials. This one's about the characteristics of polynomial functions. So what we're trying to do in this lesson is make some links between the equation and what the graph will look like. Let's see how this goes. Now, make sure you've got your graphing calculator because you need to do this along with me. So here's what I'm going to get you to do. You're going to grab your calculator and you're going to graph these functions and draw the picture off to the side here. So you can see the first one I've drawn. I haven't drawn a very pretty picture. I just got the general idea. And then what you're going to do is fill in the chart. So for instance, given this polynomial, I can see that's degree 1. Looking at the graph, there's one x-intercept. The y-intercept I can find by simply just hitting my trace button on my calculator. End behavior, well, that's how we're ending going using the quadrants. So remember, our quadrants go 1, 2, 3, 4. And turning points is how many times the graph has turned around. So let's look at the next one, and I'll show you what I mean. So what I'm going to do first is I'm going to graph this in my calculator. So roughly, again, it's not perfect, but roughly, that looks like that. Okay, the degree, well, the degree is 2. The number of intercepts, well, I see 2. The y-intercept, if I hit my trace button, would be at 0, 4. I would say this graph ends down from over here, or I would say this goes from quadrant 3 to quadrant 4, and there's one turning point. That's what I'm looking for you to do. So take the time now. I want you to graph the following 4 in your calculator and see if you can complete the chart and see if you can start to make a pattern between the equation and the information that you're filling into the chart. Okay, hit pause. I'll see you in a few minutes. Okay, hopefully you took the time to draw those graphs. So just compare yours to mine right now. And then let's go through and let's complete the table. So degree again, this one is degree 3. Now, how many intercepts? 1. The y-intercept, 0, -2. I would describe this as going down, or from Q2 to Q4, just like that. And how many turning points? Well, I see 1 turning point, 2 turning points. Okay, let's keep going. Well, the degrees of each of these is 3, so we can speed that up a little bit. Okay, how many x-intercepts? 1, 2, 3. Okay, so that's interesting. Our degree 3s have 3 different possibilities for a number of intercepts. Constant term, or y-intercept, is that. Again, I find that just by hitting my trace button right now. I would say this one ends going up, which is Q3 to Q1. I would say this guy ends up going up, so same thing, Q3 to Q1. And the last one ends going down, so I would say Q2 to Q4, just like that. Okay, and again, number of turning points, well, 2, 2, 2. So let's see if we can make some generalizations here. Okay, the maximum number of x-intercepts. Well, the maximum number of x-intercepts, look at degree 3, I've got 3. Degree 3, 2, degree 3, 1. The degree gives me the maximum number. It doesn't guarantee how many I'll have, it tells me the max. Well, the next one says the y-intercept. Well, do you notice the y-intercept is actually the constant term? The end behavior. Well, I'm going to look at all the graphs that end down. This one, and I'll just shrink this a little. This one. Well, if you notice, all the graphs that end down start with a negative. And all the graphs that end up start with a positive. So end behavior, what that's called, it's the sign of the lead coefficient. So I'm out of room there. I got to squeak it in at the end. It's the room. That's the room. It's the sign of the lead coefficient. Okay, number of turning points. Well, let's go hot pink here. Degree 3, 2 turning points. Degree 2, 1 turning point. Degree 1, 0 turning points. So guess what? The number of turning points is 1 less than the degree. So this is a table here that I would like you to know. It's really important. Okay, there's the first part done. Let's do the opposite now. Given the graph, can you tell me this information? Okay, well, how I'm going to do this is I see, look at, there's 1 turning point. So my degree is 1 higher. The one beneath it, there's 2 turning points. So my degree is 1 higher. Sign of the leading coefficient. This graph ends going down, so this will be a negative. This graph goes up, so this will be a positive. Constant term is my y-intercept. So it's down here somewhere. I'm going to say it's negative. Looks like it's about -5, approximately. The next one, constant term, right there, -1. And again, end behavior, I'm just going to describe as going down or going up, or if I needed to, I would describe quadrants, quadrant 3, quadrant 4, or on this cubic one here, I would say quadrant number 3 to quadrant number 1. So that's what I'm looking for. If I give you the graph, you should be able to give me those characteristics of the function. Okay, friends, last thing I need you to notice is how do the zeros, the x-intercepts, and the factors all work together? So let's look at the first graph here. So the zeros are here and here. So my zeros, I'm going to say, are -1 and 2. My x-intercepts, well, my x-intercept is just my zeros, but I'm writing it as a coordinate pair. And then the factors of the function, here's the really important part, friends, the factors of the functions. Well, if that's my x-intercept, that means my factor was x plus 1. And if that was my x-intercept, that would mean that factor is -2. Oh, so if I know my x-intercepts or my zeros, you can give me a pretty darn good approximation of what this actual function is. So on the next one, we have zeros of 1 and 4. My x-intercepts then are simply zeros, but written as a coordinate pair. And then my factors would be that. And you notice again, just the sign's changing, because really what you're doing is right here, you're subtracting over the -1. You're subtracting over the 4. That's why the sign changes. Okay, here we go, grade 12. So here's my zeros. My zeros would be -1, 0, 3. My x-intercepts would be -1, 0, 0, 0, and 3, 0. And so my factors would be x plus 1. When it's just 0, 0, you're just going to simply just write that as x and x minus 3. So again, if I wanted to now, what I could do is I could put a y equals here and graph it. And guess what? It might not be exactly the same graph, but what I can guarantee you is the x-intercepts will all be the same. There it is, friends. How neat is that? Now look at this graph ends going up, so I know the lead coefficient is positive. Same thing with both of these. The graph ends going up, so I would know the lead coefficient is positive. The constant term would be 2. The constant term on this one would be -1. So there it is, friends. So I need you to know how do those 3 things relate to each other. And I need you to know when you're looking at these things, I want you to be able to tell me this chart right there. There it is. See you next time.